So here we have a straight line on a Cartesian grid, which gives it a context that allows us to explore and describe it. So what can we describe? Well, let's have a look. We can describe this. This is the Y-axis intercept. Okay, we can see it equals 4, and its coordinate, if we use it as a coordinate, is 0, 4. Here we've got another point. This is the X-axis intercept. That equals -2. Its coordinate is -2, 0. We could also look at describing the steepness or the slope of the line, and we know how to do that now. We use the gradient formula dy over dx. So dy, the difference in y between 2 points, and dx, the difference in x between the same 2 points. So let's pick 2 points. Let's pick that point there, and let's pick this point there. So what's dy? Well, dy is this bit between the 2 points. That's its dy value, which we can see is 2, y being the vertical aspect, and I'll put 2 there, and the x difference between those 2 points, the horizontal aspect, is 1. So 2 over 1, so we know the gradient is 2. Okay, so they're the 3 things we've talked about so far. Now, we've also got 2 points on this line. In fact, we've got 4 points because we've got the 2 we drew, plus we've got the x and y-axis intercept. But we could put as many points as we liked out. There's a point, there's a point, there's a point, there's a point. In fact, as we talked about in the other video, a straight line is just a set of infinite points, and each point is defined by a coordinate. So we could write it as xy for one of the coordinates, an infinite number of them within a set, which the square bracket is. Now, the square bracket being a set means that there's a rule that has to be applied before a coordinate's allowed to be a member of this set, okay, or a point on the straight line. So let's look more closely at the line, okay? So we have xy pairs. So that means we know that for every x value, there's a y value. It could be one down there. It could be one up there. It could be one where x is 1,000,000 or 1,000,000,000. It doesn't matter because it's an infinite number of points, because a line has a length that is infinitely long. So we know that for every x value, there's a y value. And because it's a set, we know that there must be a rule. It can't be just any x and any y, can it? Because that wouldn't create a straight line. It'd just be a load of crosses or dots all over the place. There would be no straight line. So we need some way of tying the x value to the y value, a rule. Now, to be able to describe that, we need a language. And luckily, mathematics has the best language there is. It's called algebra. Algebra is the language of the universe, and we're going to use algebra to describe this line, and not just this line, but every line that has ever existed and will ever exist. And we're going to do it by using what's called a general form. Okay, so we're going to use a general form of a straight line. Now, we used to general forms before. In other things, you could argue that a general form of a human being is a head, a body, 2 arms, 2 legs. Yeah? Each individual human is different, but they all obey the general form, usually. Okay? Same with a car. General form of a car could be 4 wheels, 4 doors, steering wheel, engine, seats, that sort of thing. So general forms are ways of describing things in general. The general form for a straight line, using algebra, is y equals mx plus c. Okay, there's the y. That's what we want if we put an x value in. So if we put an x value into this, we should get a y value out. We get it out when we times the x value by m here, and then we add whatever c is. So we just need to know what m and c are. And luckily, we already know how to work these out, because m is the gradient, and c is the y-axis intercept. So that's the general form. What's the specific form for this equation? Well, for this straight line. Well, for every y, we have an x. Or for every x, we have a y. We need the gradient, but luckily, we worked it out up here. The gradient is 2, because we worked it out from the line. For every 1 you go across, you go up 2. So we can put 2 there. And then we also know what the y-axis intercept is, because we worked it out here, but we can see that it's where the line cuts through the y-axis. And that's positive 4. So, the equation of the straight line is y equals 2x plus 4. Okay, now, let's prove it. If this is the equation, this is also the rule that allows you to be a member of the set of coordinates that, if you wrote them all out, would create the straight line. So, is it true? Let's test some points on the line to make sure and see if it is true. So, if we look at this one down here, we can see that its coordinate is -5, -6. So let's see, is that coordinate a member of this set? And to do that, we say is, question mark, is y, so what's y in this? -6. Is y, so is -6 equal to 2 times x, -5 plus 4? So is -6 equal -10 plus 4? Is -6 equal to -6? Yes, it is. So that's one way we can show. Yeah. Well, not only can we use it to prove that points are on a straight line, we could use it to prove points aren't on a straight line. So we could pick 0, 0, for instance, and push that in. And if we put 0, 0 in, let's have a look down here. We can see it's not on the straight line, but let's test it. Is y equals 0 equal to x equals 0 using this equation? So is 0 equal 0 plus 4? Is 0 equal to 4? No. So that shows one way to show that a point isn't on a straight line. Okay, so that's the power of algebra. You know, one general form describes every straight line that there'll ever be or ever has been. We can use that through an analysis of a straight line on a Cartesian grid, which is what we did, looking at this to generate this to create the equation. So here we have 3 straight line graphs. Okay, 3 straight lines drawn onto a graph or a Cartesian grid, and we are going to magically describe them using the general form for a straight line, which is y equals mx plus c. So, to do that, our description is going to look like this, except the m and the c are going to be replaced by numbers. Now, we need to remember, first of all, that the m is the gradient of the line, and the c is the y-axis intercept. Okay, now if you get stuck, at least work out one of them, and the easiest one to work out is the y-axis intercept, because all you have to do is go along the y-axis, where is it? Here it goes, until you find where the line intercepts or cuts it, and that's the value of c. So here we can see this is -2. So we know, and you get 1 mark in an exam usually for this, that we've already got, we'll put it at the bottom, y equals, well, we don't know what m is, we know what x is going to be there, and the c is -2, so plus -2 is take away 2. So there's going to be some number in front of this x, but if you put y equals mx take away 2, you'd get a mark because you've worked out one part of it. Now, gradient. How do we work gradient out? Well, you should remember from the past that we just need to pick 2 points and then apply the formula dy over dx to them. So when you're picking points, try and pick points that are easy for you. So pick points where the line cuts through the grid lines. So I'm going to go for this one. the Y-axis intercept, that's always a good one to pick, and I'm going to go through this one here, which is 4, 0. I'm going to say that's A and that's B. So, dy dx, okay, for these is the difference between the y's over the difference between the x's. Okay, so that gives us, so let's see, we need to write the coordinates out somewhere. So let's see what AY is. So A's Y value, we know that is -2. Take away, what's the Y value of B? Well, that's 0. All over, what's the X value of A? That's 0. And what's the X value of B? So that's 4. Take away 4. And that gives us -2 over -4, which is a half. So the gradient is a half. M is used to represent the gradient. So where the M is in y equals mx plus c, we put a half. And there's our answer. Okay. Now sometimes in higher papers, okay, they don't like you having a denominator or a fraction there, so we would multiply all 3 terms by the denominator, which in this case would be 2, and that would give us 2y equals x take 4. Okay, but that answer and that answer are exactly the same. Okay, and that's how to do the first one. So let's have a look at the second one. Let's draw a line through it. Whee! Okay, so again, y equals mx plus c. So y-axis intercept first, because that's the nice easy one. So the line cuts through the y-axis. Here's the y-axis, cuts through it at 5, 6. Yeah, so 6 is one we're going to go for. So let's go 6. And then you don't have to pick where it cuts through the x-axis as well for your 2 points to your gradient, but if it cuts through the grid line straight away, you know, then use it. It's nice and easy. So y-axis intercept is here, as we said, so that's +6. So we already know, we're going to do this a bit faster, that we have y equals mx plus 6. Okay, so that's 1 mark if we do that. Then we've just got to find out this. So we have our 2 points here, don't we? So we need dy over dx equals the difference between the y's over the difference between the x's. So let's have a look. We have, let's call that one A this time and that one B. So we have, what's the y for A? So the y for A is 6. Take away the y for B is 0. The x component for A is 0. And the x component for B is 2. So that gives us 6 over 0 is 6 over -2. Okay, and that gives us -3. Now, we know that that's probably likely because a negative gradient slopes downhill. And this one is sloping down, isn't it? Whereas the other one, positive gradient of a half, it was sloping upwards. The bigger the number, the steeper the gradient. So it's 3 is quite steep, and we can see that line is quite steep as well. So there's our gradient. So all we've got to do now is fill it in. So y equals, the gradient's -3. And we'd already worked out the +6. So -3x plus 6. There is our answer. Final one then. Okay. So again, y equals mx plus c. That's a y. You'd never guess it, would you? Where does it cut through the y-axis for the... So here it is. It cuts through at 0. So in this case, c is 0. Now we're not going to put +0. So this equation won't have a number or a constant after the end of it because it's +0 is the number, and we don't bother writing that. So we've just got to work out the gradient again. So we need 2 points on it this time. So let's pick, where should we pick? We might as well pick this one, and then we go along it, up or down, to see where it cuts through the grid lines. So let's pick there, A and B, and then we just need to work out the gradient, because m represents the gradient. So dy dx is a difference between the y's over difference between the x's. Okay, so the y component of A is 0. Take away, what's the y component of B? The y component of B is 6. The x component of A is 0. Take away the x component of B, which is 3. So that equals -6 over -3, which equals +2. So the gradient m is 2. So then stick it back in the equation, y equals mx plus c. Y equals 2. There's the gradient. X plus c plus 0. We don't write 0. So there we go. Now, the good thing about all of these is you can test them to see if they work. Because if they work, you should be able to find any other point on it. So let's look at the first one. Okay, so we'll just squish this back a bit. So, where are we? Let's find a point on this first one here that works. So if we put the x value in, we should get the y value out that we can see on the graph. Okay, so we're going to pick another point. So there's a nice one there. That point is -4, -4. Okay, so -4, -4. So the y value, if we're going to use this one, is 4. Okay, so -4. So question, is -4 calculated by half times the x value, which we've said is -4, reading it off the graph, take away 2. Okay, so we have there, is -4 equal, well, half times -4 is -2, take away 2. Does -4 equal -4? Yes, it does. So we know the equation works because it agrees with one of the points we've read off the graph. Okay, so let's have a go with this second one. So let's pick one. Where's there a nice one? There's a nice one. So that's 4, -6, isn't it? So 4, -6. So does, oops, gosh, wrong color. So does y, so in that case y is -6, does -6 equal -3 times the x value, which we can see is 4 plus 6. Is that true? So does -6 equals, well, -3 times 4 is -12 plus 6. So does -6 equal -12 plus 6 is -6? Yes, it does. Okay, and then let's do the last one just for completeness. So let's pick one. Let's pick, which one should we have? This one down here. Okay, so that is -3, -6, yeah? So does the y value, which is -6, equal 2 times the x value, which, oops, this must be a bracket, is -3. I'll do that like a bracket. So does -6 equals 2 times -3 is -6? Yes, it does. So there's a really good way of being able to not only how to derive y equals mx plus c from a given graph, but how to check that your answer works. And it's also the way to check if any point is a point on the straight line, because if it is, it's a member of the set of points that makes up that straight line. So the last previous examples, the 3 of them, were diagonal lines, and we showed how easy it was to take the general form, y equals mx plus c, and generate the specific forms that describe each of the straight lines as an equation. Now here we have 2 lines that are not diagonal. They are the horizontal line and the vertical line. And in straight line graphs, these are exceptions that we need to understand. So let's try and use the method we used before. So let's take 2 points on here, and let's take that one there. Okay, so this is A, and that's B. So we know for y equals mx plus c, okay, we need the y-axis intercept is c. So where does it cut the y-axis? Well, there, -5. So we've already got y equals mx plus -5 is -5, subtract 5. And now we need to work out the gradient. The gradient is dy of dx equals the difference between the y's over the difference between the x's. So in this case, what's the y value for A? Well, that's -5. Take away the y value for B. Well, that's -5. And then the x values, well, the x value of A is -4. Take away the x value of B is +4. Okay, so that gives you -5, take away -5 gives you 0. 0 divided by -4, take away 4 is -8, which equals 0. So the gradient of this is 0. So if we replace m with 0, we get 0 times x. Anything times 0 is 0. So our answer is y equals -5. Okay, now the first thing to notice about this, there's no x. So if there's no x, there is no relationship between y and x because we don't need an x in the equation. And you can see that's true because what this is saying is that the line y equals -5 only cares about y being -5. So in any set of coordinates where you have an x and a y value, it doesn't care what the x value is as long as y is -5. And you know that's true because, for instance, this one, okay? -4 is the x, -5 is the y, -3x, -5y, -2x, -5y, 0x, -5. It's always -5, irrespective of what the x value is. So there is no relationship between the x and the y, which is why in the equation we don't have an x at all. Okay, so best way to remember how to define a horizontal line is where does it cut through the y-axis, and then it's y equals whatever that position is. Okay, can we do this with the vertical line? Well, we know y equals mx plus c. Where does it cut through the y-axis? Oh dear, it doesn't cut through the y-axis. Here's the y-axis, and it doesn't cut through it at all. Now that doesn't mean that c, the y-axis intercept, is 0, because there's 0. It means that it's undefined. There is no c, but it's not 0, because 0 is a number. Remember that. It took them 2,000 years to work that one out. So, c is undefined. Well, what about the gradient? Well, we can try and do that. We could put 2 numbers on it, 2 points on it. Let's pick that. Let's not pick that one. Let's use the right colour. So let's pick this one, and let's pick, this one. So that's A, and that's B. All right. So we know that dy dx is the difference between the y's over the difference between the x's. So difference between the y's, well, what's AY? Well, AY is 8. Take away, what's by? Well, by is 0. And then what's ax? Well, ax is 2. Take away bx, well, bx is 2. That gets us 8 over 0. And as we all know, you cannot divide a number by 0. Your answer is undefined. You get a math error on a calculator. So m is undefined and c is undefined. So there's not much left of this equation, is there? So we need to go back and look at what was happening here. Okay, so for a horizontal line, the only thing that mattered was where it cut through the y-axis, because y was always -5. So what do we think happens here? Well, the only piece of information we've really got is where it cuts through the x-axis. And if we look at that and then go up and down the line, look at the various points along that line, x is always going to be 2, isn't it? It's always 2, irrespective of what y is. So there is no relationship between x and y, so we don't need a y. We just need the x, and all the x has to tell us is where it cuts through the x-axis. So in that, x equals 2. Yeah? And if you look at it, it's got to be true, isn't it? What's the point here? So that's 2, 6, 2, 5, 2, 4, 2, 3, negative 2, sorry, comma 2, negative 1, 0. So x is always 2. And we know that because there's no y mentioned here at all. So beware of horizontal and vertical. They're very easy, but just make sure you don't misunderstand them. We've looked at how to extract the equation of a straight line from a graph. So when we're given the graph with a line on it, we now know how to take c, the y-axis intercept, out of it and calculate the gradient and then put it into the form y equals mx plus c. So now we're going to have a go at doing it in reverse. So in reverse, we'll be given a graph or a straight line equation. So y equals, what can we have? 2x. Take away 1, subtract 1. And we're going to be asked to draw a graph. Now, what we've got here is called a Cartesian grid, or a frame for a Cartesian grid. Okay. Now, you will be asked to draw the straight line graph for a domain, what's called a domain. Now, a domain in common English language means an area that you rule over. So it's the domain of the queen. Okay. So a domain of a graph is the input values, the x values that you're going to draw this graph over. So in this case, we're going to draw the graph for the domain -3, +3. So we're going to draw it for the integer values, -3, -2, -1, 0, 1, 2, and 3. That's how you represent it as an inequality. Don't worry if you don't understand it. But that is the domain. Okay, people often call it the range, but that's not the range. The range is the output values. This is the domain, which is the input values, the x values. Now, to draw it, there are two ways. The most common way is to use what's called a plotting table, because you use it to generate coordinates, and then you plot them on the graph, and then you draw a line through them. So, here's our plotting table. It's nice and easy. It's got a label on the top, which is where the equation goes, y equals 2x minus 1. Then it's got a row for x value, in the inputs, the domain, and then a row for the y values, the output values, which gives you the range of this graph. So we have x's are -3, -2, -1, 0, 1, 2, and 3. And to calculate them, well, we simply take the x value for each here and we put it into the equation. We do the calculation and see what the y value is. Now, if you're not very comfortable with doing negatives, okay, -3, -2, -1, then what I recommend is you start at 0 and do the positives first, okay? So let's say we're going to start at x is 0. So if y equals 2x minus 1, and we're going to substitute x in, and x is 0, that's the one we're going to do first. X becomes 0, take away 1. What does that come to? So 2 times 0 is 0, take away 1, -1. And we can put -1 in the correct place in the plotting table. So x was 0, so y is -1. Next one then, when x is 1, we substitute 1 into the bracket. So 2 times 1 is 2, take away 1 is +1. So we stick 1 in there, then we can do x is 2. So 2 times 2 is 4, take away 1 gives you 3. And then 2 times x, when x is 3, 2 times 3 is 6, take away 1 is 5. So we can put 5 in there. So there we've already got part of our plotting table from 0 to the positive x's in the domain. Now, if you're comfortable with the x's being negative, that's fine. Just go ahead and knock yourself out. So you could do 2 to the minus 1, take away 1. So 2 times negative 1 is negative 2, take away 1 is negative 3. So that's negative 3. 2 times negative 2, take away 1. So that's negative 4, take away 1 is negative 5. And then 2 times negative 3, take away 1. Well, that's 2 times negative 3 is negative 6, take away 1 is negative 7. So if you're happy to do that, that's fine. But there is a little trick you can use here. And it only works because they're straight line graphs. And the reason it works in a straight line graph and no other graph is because a straight line graph, by definition, has a constant gradient. Now remember, a gradient is the change in y over the change in x. Now if it's constant, it means that if we change x by 1, we're going to change y by the constant gradient. So to make sense of this, let's look at here. Negative 1, 1, 3, 5. What do we notice about these numbers? Okay, say we were going just that way. What can you see? Yep, hopefully you can see they're going up by 2. And the reason they're going up by 2 is because as we're going up in the x's by 1, we're applying the gradient to it. Remember, the gradient, for every 1 you move across, you go up or down a certain amount. Well, for us, every 1 we go left to right, so adding 1 to the x value, we go up by 2. And we can see that there. Negative 1 to 1 plus 2, 1 to 3 plus 2, 3 to 5 plus 2. So we could actually use that a to calculate the negative values of x if we wanted, or we can just use it to check it, to make sure there's always a gap of 2 or difference of 2 between the numbers. So if we're going this way, we're not adding 2, we're taking 2 away, aren't we? It doesn't mean the gradient's negative 2, it just means we're going in a different direction. But you can see there's always a difference of 2. So as long as we're going left to right, so from negative 3 up towards the positive numbers, we're going up by 2 for the y. So that's another way to fill this in. So once you get your plotting table, that's it. You just draw the little crosses in. So negative 3, negative 7 is there. Then negative 2, negative 5 is there. Negative 1, negative 3. 0, negative 1, the y-axis intercept, which we know is C. So if we look at this, we can see that's where C would go, which is negative 1, which fits in with that. So that's all good and dandy. 1, comma 1, then the next one is 2, comma 3, and then 3, comma 5. And you can see that they all line up. Now, plotting is construction, so you need to make sure you use a ruler and a very sharp pencil, draw a line straight through them, okay? Now, it asks you to draw it within the domain negative 3 to positive 3, so don't go beyond those, because that's not what it's asking. It's also very useful when you do a plotting table and put the x's in to see if you've made a mistake. Because if you have made a mistake calculating one of them, say you thought 0 was 2, for instance, when you draw the crosses out, you'll see that one of them, or more than one if you've made a mistake, is not going to be on the line, so you can go back and check that. Now, the other thing you can do, if you've got a calculator, is you can automate all of this. Okay, what you can do is you can go down here, and in your calculator, you can type 2 brackets, negative 1. And then all you have to do is edit your expression in the calculator window, so use the arrow buttons, and put the x value in there. And then press equals, and it will give you the answer. So that way, if you've got a calculator, you won't make a calculation mistake. But that's one method, on the most common method of plotting a graph, a straight line graph. So, there's another way to draw graphs, straight line graphs, and that requires you to make use of y equals mx plus c, whereas the plotting method just requires you to be able to substitute x values in and get y values out. It relies on you knowing that that's the gradient and that's the y-axis intercept. So if that's the case, all you have to do is say, right, well, what's the gradient first of all? So we know m is the gradient, so therefore the gradient is plus 2. Y-axis intercept is that. So we know C is -1. So first thing we know is that we can draw the y-axis intercept point or coordinate in. We know it's cutting at -1. That's there. So we know that's our point. Yep. Second thing to do is the gradient. So the gradient tells us it's +2. So that means for every 1 you go along, so the difference in x, you go up 2. That's the difference in y. So what we actually have to do is take our point and say along 1, up 2, point, along 1, up 2, draw a point, along 1, up 2, draw a point. And similarly, we can go the other way, along 1, down 2, along 1, down 2. We're going backwards. And then that gives you the point you need. So, okay, whoops, that's not the right thing. Okay, so along 1 up 2, along 1 up 2, along 1 up 2, and along 1 backwards down 2, along 1 backwards down 2, along 1 backwards down 2. Same set of crosses, same line through them. Either method is valid. If you use this method, you've just got to make sure you make it obvious that you've understood the gradient is +2 and the y-axis intercept is -1. Often you may be presented with an equation that's a straight line equation, and you're asked or need to extract either the intercept or the gradient or both from them. Okay, so I'm just going to show you how to do that. So the key thing is to remember the general form. If the general form y equals mx plus c, m is the gradient, and c equals the y-axis intercept. So the key thing is you can only use that if the equation is in that form. So look at the equation you're given, look at the general form, are they the same? Well, y and y, yep. 4x mx, yep. Plus c, -2, yes. So this one's nice and easy. It's in the general form straight away. So we know that m, the gradient, is 4, and c, the y-intercept, is -2. Nice and easy. Sometimes, in fact most of the time, they're not in that form, and you have to put them in that form. So this requires you to be able to rearrange, okay? Core algebra skill. So here we have 3x plus y equals 4. And we need it to be in y equals mx plus c. So we need a positive y on one side, so that's fine. So if that's the case, we're going to move the positive 3x across the equal sign, so it becomes negative, changes its sign, polarity, and then the 4 is a +4. Now it's in y equals mx plus c, so now we can see the gradient is -3, and the y-axis intercept is +4. On to the next one. So now we've got 2y equals 6x plus 10. Now this is one that often confuses people. It is in the form, sort of, y equals mx plus c. Yeah, there's a y on the left-hand side, there's an x, and there's a number, a constant, on the right-hand side. However, y equals mx plus c only works when y is 1y. And this isn't 1y, it's 2y. So we need to change 2y into 1y for this to work. And to do that, we divide it by its coefficient, which is 2. And because it's an equation and we need to balance it, we divide everything by 2. So this becomes y equals 3x plus 5. Now it's in the form y equals mx plus c. So now we can see m equals 3 and c equals 5. Okay, it's a common error that. Be very careful. It's very easy for someone to tell you in a question, here's a straight line graph where you see it and you just go, oh, it's 6 and 10. Just be careful. Next one, 3x plus 2y minus 1 equals 0. That's not in the form y equals mx plus c at all. The first thing to do is get it into that form. So we've got a plus 2y, so we'll leave that on that side. So we'll move the other two to the other side, so their signs change. So positive 3x becomes negative 3x, and negative 1 becomes positive 1. It's still not in the form y equals mx plus c, because we've got 2i, so we need to divide by the coefficient of y, divide by 2. y equals negative 3 over 2x plus 1 over 2. Okay, remember to divide both terms by the 2. So now it's in the form y equals mx plus c. So m is the coefficient of x, negative 3 over 2, and c equals a half. All right, so that's how you extract gradients and y-axis intercepts.